Hello everyone. In the upcoming video, I will explain calculations related to emulsions, preparations, and stabilization using the HLB method. The question is typically shown as: prepare the following emulsion based on the shown formula using HLB method. This formula includes lauric acid 22% weight per weight, paraffin wax 6% weight per weight, beeswax 6% weight per weight, glycerine 10% weight per weight, emulsifying system 12% weight per weight, and water up to 100% weight per weight. How to do so? How to solve this problem using the HLB method? First of all, we have to determine the type of emulsion. But how? To do so, we need to classify the formula ingredients. The formula ingredients are either oil phase ingredients, aqueous phase ingredients, or emulsifying system. Starting with lauric acid, it is an oil phase component. Paraffin wax is also oil phase component, and beeswax is an oil phase component. What about glycerine? Glycerine is an aqueous phase as it is water miscible ingredient. Emulsifying system is surfactant or again emulsifying system. Water, it is of course aqueous phase component. Now, we need to calculate the percentage of aqueous phase. The percentage of aqueous phase is calculated based on the aqueous phase ingredients. These are glycerine and water. And here in our example, as water will complete the formula up to 100%, I find it easier to do the following: to remove everything except aqueous phase component from this 100%. So it is calculated as 100% minus 22% lauric acid, 6% paraffin wax, and 6% for beeswax. What else? Of course, we have to subtract the emulsifying system, which is 12%. Then aqueous phase is equal to 54%. But what does that supposed to mean? How to determine the type of emulsion? Simply, we have to follow the following rules. An oil in water emulsion is generally formed if the aqueous phase constitutes more than 45% of the total weight of the emulsion, and a hydrophilic emulsifying agent is being used, while a water in oil emulsion is generally formed if the aqueous phase constitutes less than 45% of the total weight of the emulsion, and a lipophilic emulsifying system or agent is being used. Then, in our example, our emulsion is oil in water, since the aqueous phase is 54% of the total emulsion weight. Now, we need to calculate the required HLB. RHLB. What is the required HLB and how to calculate it? You have to remember the following points. For every oil or fat, it requires an optimum HLB to form stable oil in water emulsion and a different optimum HLB to form stable water in oil emulsion. What are these required HLBs? This table can show you a very commonly used oil phase components or types and the required HLB value for each of these components to form oil and water emulsion, and the required HLB value if available to form water and oil emulsion. Then, for example, petrolatum required HLB to form oil and water emulsion is equal to 8, while petrolatum required HLB to form water and oil emulsion is 3. What does that supposed to mean? That to prepare an emulsion with oil phase constitutes oil of petrolatum, you need to provide it with 8 HLB value to form oil and water emulsion, but to form water and oil emulsion, you need to provide it with 3 HLB. Then, what if our oil phase in the emulsion to be prepared has more than one ingredient in the oil phase? Here is the rule. If there are several oil ingredients, the required HLB is calculated as a sum of their respective required HLB multiplied by the fraction of each in the oil phase. Again, you need to find out the required HLB for each ingredient to form the specified emulsion, multiply it by its fraction in the oil phase, and to sum all of these contributes. All of these contributions. Now, let us calculate the fraction, the percentage of each oil phase component in the oil phase. It's either the fraction or the percentage. It's your call. What is our oil phase again? It is composed of lauric acid, 22%, paraffin wax 6%, beeswax 6%. Totally, these are equal to 34%. How? Now, we need to calculate the fraction or the percent, as I did here, of each of these components in the oil phase. And it's calculated as its percent in the emulsion divided by the sum of oil phase component percent. In our example again, it is 34%. Then it is for lauric acid equal to 22 divided by 34 multiplied by 100. For for paraffin wax, it is 6 divided by 34 times 100, which is equal to 17.65, and beeswax, again, the same value since it has the same percent in the emulsion. Now, calculate the contribution of each of these oil phase components in the overall required HLB. And this is equal to its fraction, again, times the required HLB of this component to form our specified emulsion. Remember, we said our emulsion is most likely to form oil and water emulsion. And 16 is lauric acid, required HLB to form oil and water emulsion. Paraffin wax contribution is equal to its fraction times the required HLB of paraffin wax to form oil and water emulsion, which is equal to 10. And for beeswax, it is its fraction times 11, which is the required HLB of beeswax to form an oil and water emulsion. Again, This is the value of required HLB for beeswax to form oil in water emulsion. Having calculated all these contributions, now we need to calculate the required HLB. How? It is the summation of these contributions. And in our case, the overall required HLB is equal to 14.05. How to deal with this number? Remember, we have to stabilize our emulsions. How do we stabilize these emulsions? Using emulsifying systems or surfactant system or emulsions, call it whatever you want. It is an emulsifying system. Remember, these emulsifying systems are composed of emulsifying agents. And here is a table to show you some very well-known emulsifying agents. The spans and the tweens are very well known to do so, with some other well-known emulsifying agents or emulsions or emulsifiers. We need to remember some important facts. From a theoretical point of view, each formulation requires an emulsifying system, emulgent blend. Emulsifying system, emulgent blend of HLB equal to the required HLB. Then the oil phase do require the HLB, and this HLB is provided by the emulsifying system in order to produce the most stable emulsion. As I said, we need to stabilize our emulsions, as these emulsions are composed of two immiscible ingredients. Now, to select a suitable emulsifying system, again, emulsifying system or emulgents blend or a mixture of emulsifying agents, we need to remember other important facts. These are, it is better to use combination of emulsifiers. These combinations should compose at least of two emulsifying agents with overall HLB equivalent to that required HLB, equivalent to the required HLB, as I said. Again, better to use a combination of emulsifiers. Better than what? Than using a single emulsifier with the same HLB number. What does that supposed to mean? It's better to use at least two emulsifying agents to provide the overall required HLB, better than using one emulsifying agent with an HLB equal to the required HLB. Mixed surfactants do produce higher interfacial coverage and consequently more continuous with less spaces and integrate film. Then we will end with a monolayer of this emulsifying system on the boundaries between those two immiscible phases, the oil and water phases. Also remember that in choosing an emulsifier blend, the effect of chemical structure on the type of interfacial film must be taken into account. And these condensed films are produced by emulsions having long saturated hydrocarbon groups, thus providing a maximum cohesion between adjacent molecules. In most cases, it has been found that most stable emulsions are formed when both emulsifying agents are of the same hydrocarbon chain. Yet, we can still use emulsifying agents with different hydrocarbon chains. This is to provide the most stable emulsion. You need to use the same hydrocarbon chains again, so we can use and stabilize our emulsions using emulsifying agents with close to each other hydrocarbon chain length. Now, based on all of what we did say, how to select these two emulsifying agents? First of all, remember the following 2 points. Select at least 2 emulsifying agents, but again, based on what? And the overall HLB of the emulsifying system should be equal to the overall required HLB. How to do so? Knowing that the required HLB of the emulsion in our example, as we did calculate, is 14.05, as you remember here. Which of the following emulsifying agents combinations can be used in this emulsion? Option A, span 20 with HLB value 8.6 and tween 20 with HLB value 16.7. The answer is yes, but why? Not only because these two emulsifying agents have the same hydrocarbon length, but because one of the selected emulsifying agents, tween 20, has HLB value more than the required HLB, and the second emulsifying agent, which is its span 20, has HLB value less than the required HLB. Again, tween 20 has HLB value 16.7, which is more than 14.05, which is more than 14.05, and span 20 has 8.6, which is less than 14.05. Option B, span 20, 8.6, and tween 40, 15.6 HLB. The answer is yes. Again, for the same reason, tween 40 has HLB value more than the required HLB, and span 20 has HLB value less than the required HLB. Option C, span 65, 2.1 HLB, and tween 65, 10.5 HLB. The answer is no. Despite the fact that these two emulsifying agents have equal hydrocarbon chain length, but because both of the selected emulsifying agents have HLB values less than the required HLB, the answer was no. Option D, sodium oleate with HLB value 18 and tween 80 with HLB value 15. The answer again no, and it is no because both of the selected emulsifying agents have HLB values more than the required HLB, as you can see. Now, we need to calculate the ratio, the fraction, the percentage, call it whatever you want, of each of the selected emulsions in the emulsifying system to achieve the required HLB. Remember, each of these selected emulsifying agents will contribute to the total overall provided to the total or overall provided HLB by its HLB multiplied by its percentage or fraction in the emulsifying system. Then we need to calculate the percentage, the fraction of each of the selected emulsions in the emulsifying system to achieve the required HLB. If the required HLB is 14.05 as we did calculate, can we use span 40 with HLB value of 6.7 and between 40 with HLB value of 15.6? The answer is yes, because one of them is one of these emulsifying agents is HLB is smaller and the other is larger than the required HLB. Now, how to calculate the contribution, the percentage, the fraction, call it whatever you want, of the selected emulsions. Of these two emulsions, we agreed that they will fit our requirement in the emulsifying system. I can't emphasize enough on the word emulsifying system, because first we will calculate the percentage of each of the selected emulsifying agent in the emulsifying system. Then we will go back to the emulsion to calculate the percentage of these two selected emulsifying agents in the emulsion formula. To achieve the required HLB, in our example, it is 14.05. If B is the lipophilic emulsifying agent, which is in our case span 40, and A is the hydrophilic emulsifying agent, which is in our case is tween 40, then the percentage of A, the hydrophilic emulsifying agent, is equal to the required HLB minus the HLB of B, the lipophilic emulsifying agent, divided by the HLB of A, the hydrophilic emulsifying agent, minus the HLB of B, the lipophilic emulsifying agent, times 100% if you are aiming to calculate it as a percent. If you just want it as a fraction, just forget about the percent. And the percentage of B, the lipophilic emulsifying agent B, is equal to 100% minus the percentage of A, the hydrophilic emulsifying agent. If you are calculating the fraction, then it is 1 minus the fraction of A. By the way, you can manipulate this equation to calculate B first. But shall we stick to this formula? Please do. Now, the percentage of A, the hydrophilic emulsifying agent, is equal to 14.05 minus 6.7 divided by the difference between the HLBs of the hydrophilic and the lipophilic emulsifying agents times 100%. And this will lead to A percent equal to 82.68%. B percent is equal B percent, or the lipophilic emulsifying agent percent, is equal to 100% minus the hydrophilic emulsifying agent percent, which is equal to 17.32. An alternative method that can we use to calculate the fraction of the selected emulsifying agents in the emulsifying system is based on the following assumption. If the fraction of A is equal to X, consequently the fraction of B is equal to 1 minus X, then 14.05, or the required HLB, is equal to the fraction of each multiplied by its HLB. As you can see, you can solve it with respect to X and find that the fraction of A is the same as we did calculate. Now, calculate the percentage of each of the selected emulsions in the emulsion. How? I need to remind you that we did select the fraction of each emulsifying agent in the emulsifying system, and these were 82.68% for A and 17.32 for B. Then 8% in the emulsion is equal to its percent in the emulsifying system multiplied by the emulsifying system percent in the emulsion. Do you remember this number? Here it is. And this will be equal to 9.92%. For B, the lipophilic emulsifying agent percent in the emulsion, this will be equal to its percent in the emulsifying system multiplied by 12. Again, this is the percent of the emulsifying system in the original emulsion formula. And the result is 2.8%. Our final formula would look like the following formula. Notice here we add the selected emulsifying agents with their calculated percentage instead of the emulsifying system. What if 600 grams of this emulsion are to be prepared? How to do so? We need to calculate the amount of each ingredient, and these are, as you can see. Please take a look and try to calculate these number but by yourself. Here I need to mention, and it is worth mentioning, some important notes, that the presence of other ingredients, particularly these that may partition into the oil phase, can also affect the required HLB. Then it is important to realize that there are some ingredients in the emulsions that do not have required HLBs but do partition into the oil phase, and this will affect the required HLB, but we will not be able to calculate it. As we mentioned, they do not have required HLBs. Therefore, it is necessary to prepare a series of emulsions using blends of a given pair of non-ionic emulsifying agents covering a wide range of the HLB values. Again, how to solve this problem? We need to do the calculations, then to prepare a series of emulsions, as we have to do during our practical session, and as you can see in the videos, then to study the stability on shelf. This is also important if the required HLB for an oil phase is not available, as you did see in the table. The series of trials of emulsions can then be assessed for stability, as I said, based on the fact that the degree of creaming or separation is at minimum at the optimal HLB value. What if the series show equally poor or equally good stability, resulting in an inability to choose a suitable HLB value? Then the total emulgent concentration, the emulsifying system concentration in the original formula, may be increased or reduced respectively, and the manufacture of the series is repeated. Before going to the additional question, I need to remind you with the effect of temperature on the stability of emulsions. This is one of the weakness or disadvantages of the HLB value. Then please study well the effect of temperature on emulsions stability as mentioned in the pre-lab reads. And additional questions for you to solve. Prepare 750 grams of the following emulsion formula using the HLB method. What I'm aiming here is to do all of calculation that we did. But as you can see here, I did add the amounts of each ingredient. And for you to simplify the calculations and to be able to use the same method I did, please calculate the percent weight per weight for each of the ingredients. This is simply can be done by calculate the total amount then divide each ingredient amount by the total amount times 100%. This will lead to the calculation of percent weight per weight. And you will find here the answer for this question. I advise you to do the calculations by yourself, then to come back here and find if your numbers do match these numbers. Thank you.